So today I'm going to talk a little bit about seawater distillation plants. And seawater distillation is when you take seawater and you purify it to have fresh water. So you're going to get a concentration of brine, which is a high concentration of salt in the water, and a low concentration, which is going to be pretty much pure water. Oh, I'm sorry. Right here, this is actually at the Tampa Bay distillation plant. It's the largest one in the Western Hemisphere. So this is a whole photo, and then this is like an inside of their micron filter. So not reverse osmosis, which is the main filtration. So I thought I'd show some pictures of local distillation taking place. I'm going to talk about the simplest process there is for like the simplest plants, because some of these plants have highly involved complex processes. So the first one is intake of water. The plants will intake millions of gallons of water, and after they intake it, it goes through a screening of like sediment or like gravel or active carbon, something that's going to take out large particles and odors of the water. It continues to go through a process where they add chemicals that make smaller fine particles coagulate so that they become bigger, and then air pressure is added to make this come to the top so they can skim it off. And then it goes through ultrafiltration, which is like very small micron filters. This basically removes all the bacteria, anything else of the water besides the salt. The water has to be very pure before it can go through reverse osmosis. Reverse osmosis membranes are expensive, and if it has a lot of, and the holes are very small, it's a very small micron filter, even smaller than the ultrafiltration. So if there's large particles in it, you'll clog them and throw them out. You'll have to throw them out or replace them. And then finally, the post-treatment, where they're going to add like calcium carbonate, fluoride, chlorine, everything that they add to standard drinking water so that it can be used for drinking or washing or other things. So I want to talk a little bit about more in detail of reverse osmosis, of what exactly that is. And so naturally, diffusion is where you have a solute that will diffuse to a pure water substance, and they will diffuse into each other until it's an equilibrium balance. All us chemical engineers are well familiar with these activities or these natural occurrences. Reverse osmosis is just that. It's the reverse of that. And they reverse this process by using high pressure. So some standard pressure they use is like 1,000 psi. I had a reverse osmosis system at my house. It used 55 psi. And it just reverses the flow. So it forces a water and salt mixture to go through a membrane and force the pure water out. It just reverses the diffusion process. This is a picture of a reverse osmosis. I'm not going to go too much into detail. It's basically a tube wrapped with semi-permeable membranes like a roll of paper towels, and the pure water flows through it and around into the main tube, and then there's a waistline for the rest of the water. So there's some controversial issues. There's a lot to mention about this, and I tried to pick topics from people that support the controversial issues rather than writing like generically. So they're a little aggressive. So saltwater distillation is far more expensive than using natural groundwater. This is true depending on how far the water has to travel. And the number one place they like to refer is California. California's natural water reserves are in Northern California. So they pump water across the entire state of California to South California. And that makes their water like the most expensive in the world, where they could actually have a distillation unit like the one they have in Tampa to produce pure water. It takes a tremendous amount of energy to process seawater, and we really shouldn't be burning any more fossil fuels than we need to be. They used to only use thermodynamics or heat energy to make pure desalination units. So they used to heat it up so there was steam and then condense it into pure water. But with the technology advancement of reverse osmosis, which is kind of recent in the mid-1950s, that has like tremendously cut the costs, and they now also have engineering techniques that lets them reuse or recycle the energy. They're able to save up to like 60% of the energy. So the cost has come tremendously down. It's still cheaper to use current natural water reserves, as long as it doesn't have to travel a long distance. But right now, that the cost of making reverse osmosis water is coming down, and the scarcity of natural water is making the distance farther, and that's going up. The primary byproduct of diesel is brine, which facilities pump back out to the sea. The stuff sinks to the seafloor and wreaks havoc on ecosystems, cratering oxygen levels and spiking salt content. A lot of engineering and regulations have changed this now to where they run the water into a deep, high current path, so that there's almost no change in salinity a few meters out. They sometimes run them out over 1,000 meters into the ocean, so that it is stabilized and does not create a salinity spike around the area. Slide. Sorry. You're okay. So some fun facts. Most of these are not that fun, actually. By 2050, it's estimated that the average demand for water will exceed the local availability by more than 120% in most of the world. So that means that the more scarce water gets, the farther we will have to pump it, the higher the price will come, and that will continue. As technology advances, though, reverse desalination units, the price continuously goes down. So right now, desalination units are booming pretty much. They're popping up all over the place. And that will continue to happen as water becomes more scarce. And then I wanted to give some idea of how much water we use a year, because you don't know how much goes into the food you eat and things like that. So the minimum water each person requires for all uses is 264,000 gallons per year. That's a couple swimming pools worth of water, right? So let's go. Researchers, here's the actual only fun fact here. Researchers both from University of California and the University of Florida were the first successful produced fresh water from seawater using RO in the mid-1950s. So right here in our chemistry department, we developed the technology, or discovered the technology for reverse osmosis, and it was a major breakthrough in, I believe, 1957 to be exact. Saudi Arabia leads the globe in production of desalinated water, and with a daily production capacity of 900 million gallons a day. And they get 50% of their water. Saudi Arabia is 95% a desert. So instead of pumping water across multiple countries, which would make it very far to travel and very expensive, they are able to produce water cheaper with desalination units. So here's some pictures. I wanted to find some pictures that were of the most advanced desalination units around. And this one is in Saudi Arabia. That's a power plant right next to the desalination unit, where they use the leftover heat energy that would usually be heat energy to waste energy to boil water and then condense it. So, and they also use reverse osmosis membranes. And inside one of these plants, I found a picture to show exactly like how advanced and complex their setup is, and you can see there's just tons of chemical engineering going on all over here. Each one of these tubes are 6 reverse osmosis membranes in one, and they use 6 because that is where the pressure and the cost is most effective. This is apparently the most technology advanced plant in the world. It's in Israel, and they produce 500 million gallons of fresh water a day from one single plant. And inside, these are just all their reverse osmosis membranes running down the hall. And these are just my sources here. I tried to show that where I got some of my design ideas. Thank you. Does anyone have questions? Okay.